So when addressing the likelihood column, you have to bear in mind that we are actually applying the maximum likelihood methodology, and we're doing this in order to choose parameters in the Garch model that maximize the likelihood of observations occurring. So what does this mean? The parameters in this case are the trial coefficients that are down here. So these are just trial values I have for the coefficients omega, alpha, and beta. And we're going to use the maximum likelihood methodology to estimate them. And we're going to use this function here, this equation. So the first step would be to input the negative log, negative natural log, so it returns the natural logarithm of a number. So we're on the right track. And in this case, we then input the variance, which is what V stands for in the equation. And then we're going to subtract the squared value of the return. And then we're going to divide by the variance again. So we're going to then pull down this formula to populate all the cells. And we've done so. So the next step will be to sum. Actually, you need the equal sign there. But to sum all of these points. So that's the way we complete the function. So I made a small mistake there, but it's easily correctable. Okay, so now we have completed the function for the likelihood. So the next step is to actually use solver. So I already have this summation highlighted, this summation cell highlighted. I'm going to go to solver, and this is the objective, and I want to maximize this. So I want to find the maximum value function of the equation. And I want to do this by changing these parameter cells here. So I actually made a mistake there. Let me reset it. These are the cells I want to highlight. Okay, good. So everything else is in order. And so I'll let solver do its work. I will keep the solver solution. And then you notice that the trial values have changed. And this is the maximum value function of the equation. And these are, back to these coefficient values, these are the values which allow the maximum likelihood of the observations in the data set occurring. So the next step would be to calculate the long-term variance rate, VL. So again, what I'm going to do is I'm actually now going to apply the new coefficient values like so. Okay, and so this actually gives you this is just a representation of this equation here, and this gives you the long run variance. And now in order to calculate the long run volatility, or the long term volatility, I should say, I just square root the long run variance. So there you have it. That is the long run volatility. Okay, and that's just the square root of the long run variance. To add to this, this long run volatility is actually equivalent to approximately 4.3% per day. So that's it. That's how I got the long run volatility from the long run variance. And it's all based on the manipulation of this equation.